Okay, hello students. Here, this is lesson number 5.4, exponential regression. So I'll go straight away to the main. Last time we did manually how to find the equation, exponential equation. Uh, so remember this: y equals a times b raised to x, where a is a non-zero and b is a positive real number. All this we have gone through. I'm gonna go directly to the problem. Sometimes we are given a table with the x's and the y's, and then we need to figure out an exponential model that will fit, that will represent this. So how do we do this? And all you do is using the calculator. So let me pull out the calculator. Okay. So the first thing you need to do in the calculator is you have to clear any of the earlier list of numbers that we had fed. So that's the first thing. So this is the calculator. Make sure you click on stat and go down to clear list and enter, then open parenthesis. And second, go to L1. Okay, this one means L1, comma, then second, L2, comma, and enter. So this clears the whole list. And then go to the stats and we have to put the new numbers. And remember, you have the packet with you, and the numbers for X was 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we had 9 of them. Okay. Then go to up, and then the other numbers are uh, 3, 5, 7, 11, 19, 28, 41, 67, 95. Okay. So once we do this, we have to create an exponential function. So how do we do this? Same thing, stat. Next is calc. Scroll down all the way to find exp, and you can see this exp basically means exponential regression, and enter. And we have the first list. The first column is x list is the L1, y list the L2. And let's also try to. Before we do this, I forgot to do the scatter plot. So let me go second, clear this, everything clean, and then click on second, stat plot, then put it on the first one, enter, and you make sure the blinking, that means it is on now, and then you can see clearly here, you click on the zoom and go to 9, so then you can see the scatter plot of the whole thing. See? And you can see the graph is not a line, but it is like goes slowly, increases, and then increases faster like this. So now what we have to do, also you can check in the window also. So the lowest the window, see this x minimum is 0.2, x maximum is 9.8, y minimum is -12. This -12 just to show below x-axis, and y maximum is 110 because 95 was the maximum. And now once you get this, so just want to show that, okay, so we have that scatter plot. This, I want you to manually also do this. It's better to do this. So I guess on your paper, make sure do this manually just to understand it. So you have x-axis and the y-axis. And because the numbers where you can say, okay, it starts with 1, right? 1, 2, 3, 8, and 9. And the minimum here was, of course, the based on what this one, I'll put it like -10 here. And we have 100, right? So I'll go from 10, 20, 30, like this. So spend some time on this just to get a feel of what is exponential uh, scatter plots in exponential form. 80 and like that, 90. I don't have enough room here. And then you can see the first one is 3, so somewhere here. 1 is 3, 2 is 5, 2 is 5 halfway down, 3 is 4, go down, and then 4 is 11, little above 10, 5 is 19, 6 is 41, 7 is 67, 8 is 67, like this. So you kind of get a scatter plus a plot of this, and you can write those numbers, whatever the numbers on your paper, so that you get your full points. Okay. Once you do this, now we have to graph the. Our goal is to find an exponential model that shows a graph that almost the best fit graph we call it. So it doesn't go everywhere, but some of them will be a little above, some will be down. But mostly we want to see best fit graph. And that graph is what we are trying to figure out y equals a times b raised to x. So all you do is, let's go back to the calculator. Here, so click on the stat and then click on the stat, right click, go down all the way to exponential, see, enter, and then go down, and here you need to store this in the Y editor. So you click on VARS, VARS, can you see the VARS? And then right click and you enter 2 times and the Y1 comes there, go down, enter. You can see clearly Y equals E. So you already get that what is E stands for, what is B stands for. And let me write that equation. Okay. So what did you get is your equation is y is a times b raised to x. So this y is, and always write 4 place decimal, 1, 6. And that 6 becomes, I can round it. So instead of this, we can round it to 1.841. 6 becomes 7, see, because the actual number is 1.84167, right? We want to have 4 places. And because this number is greater than equal to 5, this number is increased to 7. And that's why I wrote that. And then the B is this one, 1.5443. And then I think I have to round it and become 6 here, raised to x. So what is that B here? So this part is the A, that means when it is 0, it is like 1.8417. And what is B means? B is 1 plus R, and that is given to you is 1.54036. I think 15444 should have been, this is 4, because you want to have only 4 place decimal. So it is 1.534. So you get like this. So this can be written as 1 plus 0.5, 4, 4, and 4. Now, what does this basically means? 1 means the whole 100%, means everything, the previous one plus, and this means you have to move 2 places decimal, that means it is 54.44%. So this is that R, which is percent increase. So there is a percent increase. Every increase in X, for one increase of X, the Y increases 54%. So this is percent increase. Okay. And that's why we say now we need to see also the graph of that. Let's go back. And how do we, and you can see here, since this one is already stored at equation, see, it's the same thing. And you just graph and you can see nice graph going through this. And we can plug in any number now. Let's figure out, let's say we want to figure out, uh, now this is the equation, right? This is the equation. This is the linear model. Okay, so all you do is, suppose the question was, if x is, so suppose x equals 5.5. How do we find y? What is y? So question is, how do we find this? You can see we will click on, there is a table set here and there is a table here. So what you do is we click on, let's set up this, or you can directly do like this. You click on the graph. Where is the graph? So click on the graph and click. There's a calculation. See here, the blue color is CLC. So second calc, and you want to find the value, and that is at 1. So I'll click all the way and enter. You want to put 5.5. You see, you get the answer. So you get this answer. This is called interpolation, is because this 5.5 that we had, remember, this is the x value takes from 1 to 9. Anything values of x from 1 to 9, it is appropriate to use the regression model. But if you, that's called interpolation inside 1 to 9. If you have take x beyond 9, let's see, let's put 12 and see what happens. So we already got this one. And instead of this, let's do calculate a value with 15 maybe. Okay. You see, when you do this, and it's an error because we went beyond. So even though we could do another way also, click second quit, and you can table set. See, there's a table set here, second, and you want to click start, so beginning with 0, then you go down, and here you ask, means you're going to feed manually whatever there, and now you click on, so this is enter is already done for you, okay, and enter, and second table, and now you want to put that 5.5 and you see that the answer, okay, and if you want to do 15, then you can say 15, you get the answer, but that's not appropriate to use, even though this you get the answer, but it's not appropriate to use. That's called extrapolation. So if you take anything, let's say this we already did, but if you put x equals 15 and then y, even though whatever the answer is, this is not appropriate. Why it is not appropriate answer? Because this model works only for x's between 1 to 9. See? So anything beyond the range of this will not help. This exponential regression model will not help. So hope that helps. We will do one more and really understand this. So this next question example is, you see the example number. So this is done. There is one. This is about the COVID cases and the number of days after January 20. So this is, so January 20 is like a 0 day. So what we'll do is we'll fit this all these numbers from 0 to 8 by axis. This numbers I have this thing. I'll put this. Yeah, so So let me go back to the calculator, clear everything. So how do you clear everything? Stats, go to clear list, enter, open parenthesis, second L1, comma, second L2, and then close it and everything gone. See, if you click stat and edit and you see there's nothing there. So here you have to put 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. 8. So this 0 basically means that's the January 20. That's the start. So this is where it starts 0. Okay. And the next one is 278. Okay. Sorry. That's made a mistake. That's 0. 278, 326, 547, then 639. I hope I'm putting it right. And 916, 2000, 2700. 4400 and 5970. All numbers are done. So once you just want to make sure they are correct, 27 or 278. First one is 278. 278. Okay, then 326, 547, 639, 916, 2000, 2700. Okay. So once you did this, then you have to have a scatter plot. How do you do this? So again, click second this, and it's already on, and it's blinking. See, you can change this to magenta if you want. Some students like this color and enter, or you can zoom and go down all the way to zoom stat. And there you go. You get the scatter plot. Again, as I said, you have to graph this. So you may be wondering, how do we graph this, right? So if you want, you can see the minimum we have is, so at least this start with 0 to 8. So this will be 0, 1, 2, 3, 4. So you can do like this. But the other numbers is 270 is the start, right? So I'm gonna start to put two lines and say, okay, this is like 250. So you can see 250 and it goes to all the way to 5,000. So I'm gonna start with 250. Maybe let me start with 500. This is 500. And then 1,000, 1,500, 2,000, 2,500, 3,000. And like this, you can do the graphing. 3,000. It doesn't have to be perfect. Okay. Sorry, this is 4,000 and 4,500. And likewise, you start graphing like this, they will get point like this. Okay. So you spend time on this, but the question is asking us is what is so the question. Let's go back to the question. You can see the question is asking. The first question is let x be the number of days after 2020. That means January 20. See that January 20 is the start, and y is the how many cases after that. And we have to find. You have to use exponential regression to fit a model to this data. So what do we do? Go back to the calculator. Okay, now there is a blue line. Can you see? You have to clear that. Click on the Y and clear this. We don't want, that's the old one. So now we did the stat plot already, see? So this part we already did by clicking on, stat plot. No, sorry, I'm making a mistake. Stat plot, we did this and go down all the way and then zoom in 9. So that way you already have this. Now we have to find out the best fit regression exponential regression to fit a model. So how do we do that? So stat calculations, go all the way to exp, enter. So we already have this. This is where you do was right click, enter, enter 2 times, and again enter, you go and 4 times you have to do, and you get the answer. So the answer is, so your equation is y is a b raised to x. So your a is 229.91134 times, and the b is 1.5020. So what does this b basically means? We want to know what is the percent in. We can write this as like this, and this means originally it was whatever the previous one, plus we can move the decimal 2 places and write like this. So it is like R, the percent increase each day, the percentage increase is this. So this is R is 50, 50 point percent increase. So now the question is asked, so this is the A part is done, and the B part says, what do you think is on January 25? Now January 25 means the starting was Jan 20, then Jan 21, Jan 22, Jan 23, Jan 24, and Jan 25. So how many days? So you get from here, this was like 0. This is 0 day, 1 day, 2 days, 3 days, 4 days, and 5 days. So all you do is for B part, if x equals uh, x is 5, and then you get the value of y. Let's put it. To go back to the graph, uh, I think oh, I'm clicking on this one. So graph, okay, and see the graph also shows you because we already had fed it. And click on second calc. And you want to find 5, right? Value when x is 5. You get the answer. See? So you get 1700. So when x equals, you can see, so when x, so this is the B part. When x is 5, the y is 1757.7, which is almost like 1758 cases. Okay. Now the C question is asking is, we know it is not wise to extrapolate beyond the original data set, but in some cases we use the extrapolation to help decide what to currently do have. Imagine you have a data and it is January 29. You want to give a warning based on this, and you want to predict what will be in 12 days. 12 days from now. So if you see this go back all the way, this is what I was talking about. I wanted to read this. Imagine you have the data and it is January 29, okay, and you want to give warnings based on the model and show what the predicted value would be in 12 days from now. That means 29 is like whatever that 29. And at current growth rate continues, if the same thing continues, find the total number of cases. What does this basically mean? If you are confused, what this means is, here is the thing. I made a nice presentation. So January 20 is the 0 day. So that's like a 0 day. January 21, Jan 22, Jan 23, Jan. And this is what we already found. Remember this? We put 5 and we already figured out. Here is the answer. On the January 25th, there were 1,757 cases. Now, the, from January 29, from after January 29, he's thinking about what about 12 days after January 29. So basically, that means this 29 from 0 to here is 9 days, right? So 9 and plus another 21 days. So this will be 21 days. So this becomes 0, 3. That means 30 days from here. So if it is 0, that means we have to put x equals 30 and see what's going on. Okay. So in the calculator, back to the this, and if I click second calc and put 30, you'll see you won't. It will show up error. See why? Because we did only for uh, that was valid only for till 8 days, right? Anything more than 8 days, no. Look at this. The data is till 8 days. Anything beyond it, it won't be appropriate. So how we can do this is you click on second quit. Let's do the table. See the table here already, and clear this. We don't want this. Okay. Just delete this. Okay, delete. So now put x equals 30 and enter. You get the answer. So what this basically means, so on your calculator it shows you when x is 30, your y is 59E7, right? What it means is it is like this times 10 raised to 7. So what does this basically means? We have to move the decimal 7 times. It means it will be 459. So two places are done and then still we have 5 more to go. So you put 5 like this, and you get 45 million, see, and 900,000. So that's like 45 million and 900,000 cases 12 days after 12 days after Jan 29. So I hope that makes sense to you. So hopefully you understood. So this is called extrapolation because it is not appropriate to use this, but we can always give as a warning to check how if this really continues and you want to know like this all the way till like this until 30 days, and you can maybe it goes like this, something like this, see, which is like 4 million, whatever that is. So I hope this helps to understand the exponential regression, but which is the best fit graph for the data. So let's go to do another one. And this is an example of uh, okay. So this is example number 3. Talks about I want you to read this. This is about blood alcohol level. So BAC stands for if when you consume alcohol, and depending on how many shots you have, maybe beer, and these are blood alcohol level is shown here. And what does the Y stands for relative risk of crashing? It means compared to the person who did not drink, how many times more than a person who did not drink? Let's see here, 0 is 1, consider. This means suppose somebody had a 1 beer, that means this is like 1 times a person who did not had beer. So like that, let's see point 0.09. What does this mean? This basically means the chances of a person having blood alcohol level this will be 3.5 times the original one, a person who did not even had a drink. So that's all this means. A person with blood alcohol is 0.13. His chances of relative of crashing, meeting with an accident will be 12 times, and likewise. So all you do first is, oh, they already gave you. The relative risk is a measure of how many times more likely a person is to crash. So for example, a person with a BAC level of 0.09 is 3.54 times as likely to crash as a person who has not been drinking alcohol. Now the question is, first step is, we are going to put this as x and the y's, and let x represent the BAC level and y represent the corresponding relative risk. Use exponential regression to fit. So all you do, go to the calculator. Okay, here is the calculator. Go to the stat, make sure everything is cleared. I put those numbers already there. And you can see if I click on stat and edit, I already have those numbers. This is all. The first list is the BAC blood alcohol level. The second is relative risk. How many times to the person who did not drink. So these numbers you put, and then we want to have a stat plot. When you here, put it on. Sorry, put it on. Go down and magenta and zoom. There you go. If you see, you get the scatter plot. So once you get a scatter plot, we need to also calculate the regression, exponential regression model. So click on right click and go all the way to 0 exponential regression. Here it is. Enter. I think I messed up here. So go click. If anything, if there is an issue like this, click on second mode. Okay, and then here it is. I want this one exponential. Click on. The first list is showing L, X, Y. Here you need to save it in the Y editor. So click on vars, right click, enter 2 times, and then go down and calculate, and you get the answer. See, so you already get this equation. Looks really crazy. Let's put it. So you get equation is y equals 0.5830. I'm going to use only 4. And the other one is, it shows 2.20. Okay, 7202133 times 10 raised to 10. See this? Raised to x. So it's like quite a big number. What this basically means, your b value is, these are 1, 2, 3, 4, 5, 6, 7, 8, 9. Just want to make sure we have that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So the b is, it is, I have to move the decimal 10 times. 2, 3, 4, 5, 6, 7, 8, 9, and one more zero I'll have to put. So it is 2207202133, and then 0. See? So you get 22 billion, then 72 million, 21,000, and such a big number you get. B equals. So the percentage is so high. This is okay. So that's the answer. Now, what we do next is, a question is asking you, if you see the question there. So this is the exponential model we already got. Okay. So you can write this answer is y equal 0.583 times, and this is 22. I'll have to take everything, 0.72 raised to x. Now next is next question. What about if a person has a blood alcohol level, which, or a person who is 160 pounds and he is 0.16. So this you have to put on the calculator. Now 0.16, it is within interpolation. What is interpolation? Basically means the value of x is within the range of, because x's range from 0 to all the way, the maximum is 0.21. So this 16 is within this range, right? So we can find. So how do we find is, okay, let's see the graph also. I think we forgot to put the graph. You click on the graph and you can see nice graph there. And then we need to find second calc, okay, any value. You have to put 0.16, 0.116, you get the answer 26.34 times. So this answer is means, when you go back, 26.34. Mm, where is my? So where are we now? Forgot now. Oh, the one, it was 26.34. So I go all the way here. So that means this is 26.34. What it basically means, that when the BAC level is so much, so there is a chances of accident to occur is 26 times the person who did not drink at all. Suppose this person is sober and his BAC alcohol is 0, so he did not drink. Okay, because his crash is considered like a 1, means just a 1. And compared to this, then the relative to this, then the other person, another guy who is 160 pound, okay, so he drank a lot of beer here. So he's like, that means his chances of meeting with an accident is, he is 26 times the person who never had a drink. So that's the understanding of relative. I hope I made sense, and that's it. Let's move to another one. Okay, so the next is the exercise. So the exercise, the first example is given, does not say anything. All you do is plug these values of x and y. X is 1, 2, 3, 4, 5, 6, and then plug this, all this, and do the same thing. So I'm gonna skip this. I want you to really do by yourself, figure out y equals this and this one. Two examples you can do yourself. I'll go directly to the one that says a student is graduating, and after 1 month, 2 month, 3, 4, like that, how much does he credit card balance. So first 1 month his credit card balance 620, and then he's spending the using the credit card, so his debt is increasing. So 620, the next month is increasing. So let's put this one and find the regression model. So I want you to take the calculator. So let me pull this up and clear everything stat and go to pull, enter, open parenthesis, second L1, comma, second L2. I'm doing it fast, so you know. And then, so that clears everything. Go to stat list and put those numbers. And the numbers start with 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Then we have the next one. I'll go to, I think I made a mistake. 1, enter, 2, 3, 4, 5, 6, 7, 8. And then go back and then put the first. So 1 month his credit is he owes 620, then 761.80, 899.80. I think the previous one is 761.88. Okay. And then the next is 1039.93. 1039.93. Okay, so this is how you go on putting 1270. Then it is 158.9.04. And then 1851. Okay. Last one is 2154.9. Okay. I want to make sure what is the mode here. We click on the mode and want to see the floating. Let's put it at least two place here. That's why it's not showing up there. Then I click on stat, enter, and see. Now I can see those numbers, all those numbers, at least two place. Okay, next is you need to know the stat plot. Click here, enter, go down, and zoom 9, and you get the graph. All you do next is stat, right click, go down for regression. You can press 0 straight away. So I could press 0, the first list, second list, and this is where you want to store the equation. Right click, enter, go down and calculate. So that's the answer. It's done. So your answer is y equals y equals 522.897 times 1.196 raised to x. And they also ask you what will be happen after 1 year. After 1 year, how much does he owe? 1 year means x is 12 months. So all you do is you put 522.897 times 1.196 raised to 2. Now, if you see this 12 months, when you try to calculate here on the using the graphing calculator, because 12 is beyond your 8 months, right? because your table gives only 8 months. So if you put 12 here, okay, the graph also shows, and you want to see calculate and put 12, that's like 1 year, and you get error. And that's why you have to go and mm, calculate. Sorry, you have to go to the table. So second table, and we'll clear this or delete this. Mm, mm, okay, and now you want to put 12, right? So here, just type in 12. You get the answer. So that's the credit for so much money he owes to the bank. Okay, because this is extrapolation. This is beyond. It's not appropriate. And this equation exponential regression is appropriate. This exponential regression is appropriate only when for x's between 1 and 8. Anything beyond is extrapolation. Okay. But if you take in between numbers, it is interpolation. Hope that if you see the next problem, you see the question number 4 talks about you are given a drug which is 1000 milligram and the time is given 04812 hours and how much is remaining. That means in the beginning you are taken 1000 and you can see it decreases every hour. So construct exponential regression model for the amount of drug in the body after so many hours. And also it's asked you what about 10 hours. So let's put these numbers in the calculator. So first let me clear all this and for open parenthesis second L1 comma second L2 close it here and put stat and enter. The number we'll see here is 0, so put a 0 first, then enter, then it is 4, 8, 12, 16, 20, and 24. So this takes care of how many hours have passed since 1000 milligram drug was given in the bloodstream via IV intravenous. And your first was 1000 milligram. Then it got reduced within 1 hour to 580, almost half. Then went to 290, then 162, 93, and 27. And then stat plot, you can see, put it on, enter, go down, 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 and you get the graph. See how beautiful graph. I mean, you have to click on zoom, and then 9. The old one is, we'll clear this, we don't want, so you have the graphic. So there's the exponential decay here. We need to figure out what is the equation. Go down to 0. And we need to say the exponential equation stat no sorry stat I made a mistake calculation and I go to 0 and I need to store it. To do that I go to vars, right click, enter, go down and enter and you get the equation. That's it. So see, so nice beautiful equation you get and you get equation as See, so y is 1024.525, and this is 0.857 raised to x. And then the question is asking what if you put about after 10 hours, x equals 10, right? So you put y equals the same thing, 1024 point. You can put this 0.857 raised to 10 and you get the answer. So on the calculator, you can just plug it in. You go to the graph first. So here is the graph, and you can see that decay graph also showing. And second calc value, and it is 10. It is interpolation. It means this is inside. So that's that much of milligram of drug will remain in the bloodstream. But if you put anything beyond 24, you put 27. If you click on second calc and put 27, you'll get error because this is beyond. And that's why you can use table. Let's clear this and put table. So second table, and you can put here. Let's see, 27. That gives you the answer. But this is not appropriate because this is beyond 27, beyond the range of the how many hours passed from 0 to 24. Hope this helps. Then there is another two questions. They are similar. I don't want to waste. I think you can do it yourself, but still I feel I don't know. This one is talking about when the movie is being already shown. The first week is so much money in millions. Second, so you are given this. All you're supposed to put this numbers and find an exponential regression after so many weeks, and you can predict in 6 weeks also. Using the model, can you find which week will be and what will be below 1 million? So let's put this equation. Okay, so here is the thing. This is the thing. What I did is I've already put on the calculator. Here it is. And I want to trace it and start plot, enter, and go all the way. And you can see the scatter plot and zoom 9. You can see if there is that blue line is from the previous example, I have to clear that. Okay, yeah, so this is the four things. We can also use now to find. Let's find the regression. So directly put a 0. You know why? L1, L2. Let's store. How do we store? Was right click and 2 times, enter down, calculate, and you get the answer. So this is the equation, and then we need to figure out. So write this on your paper. So in the beginning it was 1024. When that's when 0, and then here we have to calculate it. So stat calculate. Sorry. And then let's graph also and see the graph. So this is the exponential decay there. And now we need to calculate after 6 weeks. It's asking you what is the tickets. What would be the model? What would the model predict first? Now you remember 6 weeks is beyond 4 weeks because they give us only. If you trace this, sorry, second trace. This is the graph, and you click on just to trace. So it starts with 474. The next one is. So this is how you trace it. You don't have beyond 4. That's 4 weeks. But they're asking you the question number B is asking what about 6? So you'll have to do second table, delete all this what is not required, and just put 6 and you get the answer. So that's like 7 million and 236,000. So that's the answer. Uh, and the question also is asking what about will it ever be below 1 million? So for that we put 7 weeks, 8 weeks, and you can see if I put 9 weeks goes below. So after 9 weeks, that will be lower than 1 million. That's what that It means. I hope I'm making sense to you. Okay, so that's all. I think I finished, and you have to complete the work by yourself. And we will begin the next class with 4.1. Thank you.